Good day. It's quite windy today, and I just make this quick video repurposing some old maximum demand or watt meters or kilowatt meters, megawatt meters, whatever. They're actually quite nice meters, and they have, the beauty of them is they have a linear scale, and it's not too hard to convert them to measure, make them measure consumption. So I have calibrated this particular meter up to in kilowatts, or correction, actually in watts. So it sits around the 6,000 mark. That's a 6,000 watts instead of kilowatts. And I've done that by means of modifying a CT. So got here sitting, just experimental. That is 400 to 5 ampere CT. And I've just been experimenting with the winding ratios. So 400 to 5, it's upside down. And I put about 12 turns on it, on the primary, which is the mains, the 230, 240 volt mains, which gives me the right reading, which I'm quite pleased about. So the load is 27, the meter stays at 1.4, it's about 26 ampere. I'll drop off, it's from a couple of heaters which I got sitting here as a load bank, a regular load bank which says featured in more videos. So then I got this check ammeter sitting at just under 4 ampere. So I needed a current about 3.8 ampere to get my main meter reading correctly about 6 kilowatts. Oh, it's getting hot now. I'll just turn this thing off. And yeah, that actually works quite well. I'm quite pleased with it. So what have I done? Here, I'll show you the nameplate data. The CT is 400 to 5. So I put 12 turns on it. So if you make a 40 to 5 CT, you put 10 turns on it. But a lot of these watt meters, they are actually 110 volt meters, so they need to be partially converted and matched. So another thing I had to do is put a small transformator on here, 220 to 100 volts. So it's a 110 volt meter, but it will run fine at 100 volts AC, so there's no problem there. So yeah, I've connected it up, so 110 volts to the meter coil for the potential coil, and then the mains goes through the current via the CT, current transformator. So the green winding, I had heaps of this green winding, that's the primary coil, which is in series with the actual load. So I'll do a SketchUp for this anyway, so you guys can see how I've done it. But yeah, it's really good to repurpose those meters, because I have tons of those meters, and you might be able to get them from an auction or wherever else, but usually get M meters. But the watt meters actually quite nice to have for yeah, experiments as a measurement, and they can be wired up in series with an M meter as well. Here are two other meters. They're nice linear scale again, 0, 1, 2, 3, 4 thousand kilowatts, and the other one is a megawatt meter. I'll turn it a bit back. So it's also linear scale. That's the beauty of these type of meters. Like M meters usually have a non-linear scale. And yeah, I'll show you the back of that little meter panel I made. So the brown wire and the light blue wire, that's the 110 volts from the little transformator. And I got the currents, that's these two black ones. I just use one of the current coils. There's actually two current coils, because these meters are 2 watt meter meters, so there's a current coil here and there's a current coil there. It's a bit of fiddling around, but you can get the things to work quite nicely. So yeah, I'm quite happy with it, and I'm going to tidy this up a bit more, and then yeah, draw the diagram for you guys, and so you can make a thing yourself. It's just a rough calculation. 230 times 26, 27 ampere gives me about 5.9 kilowatts, 6 kilowatts, so that's quite close enough for that meter to read. There's the back of the other 2 meters. Yeah. Okay, here got the schematic written up. Shouldn't be too complicated. So you got the P, active power, and the neutral. 230 volts comes through here. That's the, in this case, 12 turns. That's the green wire on the CT I made. Load, cross that here. Load, lamp, heaters, whatever. We turn the small transformer T1. That's the 110 volt transformator. Primary winding is in parallel with the mains. One 10 volt winding comes out, goes through U1 and U2 terminals, the other terminal goes to the neutral. Then we've got the CT here, 12 turns in, and 5 ampere winding goes to I1, I2 terminals, or whatever it labels. It's for current on the wattmeter, and it yeah, it works quite well. So yeah, that's a simple schematic. Any questions, just put it in the comments and I'll see if I can reply to it. Thanks for watching.